Okay. So, like I said, we brought up the Desmos scientific calculator. We're just going to let it hang out for a moment. Then we're going to go to the worksheet.
Is this what we've been doing? Like the...
It's still probability, but different than what we've been doing. But it's still in the probability section. So, what we're looking at today from the top, you can see is permutation and combination. But that's not the very first thing we have to talk about when we're doing permutation and combination. It's the fundamental counting principles. So fundamental counting principle is the first thing we're going to talk about. A little bit smaller. So on this, if I've got two different colored hats and I have two different colored jackets, I want to figure out the different ways I can answer the phone. It's okay.
Just wait, I can't do that. J Mark 2021. J Nard. N-A-R-D.
Okay.
N-A-R-E.
All right, no problem.
J Nard. N-A-R-E-D.
So get them fast, use to sign out on the clipboard. Okay.
J.
All right. Bye.
N. A. R.
You're leaving.
Really?
Your mom's here.
E.
Oh my God.
Wait, give me the rest. N-A-R-D. E.
And go to Miss Matthews and make sure you sign out on the clipboard.
E-B. No, 2021.
Okay.
Dot 2021? 2021.
You good? You good? Okay. So we've got two different colored hats. We got a black and brown hat. If I wear the black hat, I could put the blue jacket on or the green jacket on. If I've got the brown hat, I could put the blue jacket on or the green jacket on. So over here shows me I had 1, 2, 3, 4 different ways I could wear two hats and two jackets. Now this one isn't too big of a deal because there was only 4 things in the end. But depending on how many choices there are and how many different things you might be wearing, it could get very long to do this tree. So we end up having something known as the fundamental counting principle. So the easier way as opposed to doing the tree is if there's 2 types of hats and 2 types of jackets, my multiplication dot disappeared. There should be a dot down there. Is to multiply and you get 4. Now I'm going to show you another example. So let's say we're getting a pizza. And we have 3 different pizza crusts we can choose from. So 3 pizza crusts. Let's say they have 2 different types of cheeses I can pick. So 2 cheeses. And I've got a coupon for a 1-topping pizza. So I'm only going to be able to pick 1 topping. But there's lots of toppings to pick from. There's 15 toppings. But I'm only picking 1 of each. That's kind of the key is I can only pick 1 of each. 1 type of crust, 1 type of cheese, 1 type of topping. Now, yes, I could do a chart like this, a tree. I'd have the 3 pizza crusts. From each pizza crust, I could have the 2 cheeses, 2 cheeses, 2 cheeses. Well, that's not horrible, but then I'd have 15 toppings. Okay, that would take forever. So instead of making this big old tree, you can just multiply all your choices. 3 times 2 times 15. So 3 times 2 times 15, I end up with how many different ways I can make my pizza. And what is it?
90.
90. So there's 90 ways I can make my pizza. And remember, that's if I only pick 1 of each. I can't put multiple toppings on my pizza. It's just 1 of each. So that's the fundamental counting principle. That's kind of one thing that we're looking at today. Any questions on that before I slide it on? Sliding on. You good? Permutations. So this was kind of the title of the worksheet in general. So permutation, an example of that is a car dealer has 3 cars to display in the showroom. How many ways can he arrange the 3 cars in a line? So it's a permutation because the order matters. There's a certain order he wants to put these 3 cars in. And I want to figure out how I can actually do this. So in this example, the 3 cars available for the first position. Well, once you got the first car in position, then you can pick 2, then you can pick 1. So therefore, you can multiply 3 times 2 times 1, and that would give me 6 ways. Now that's not too bad, because it's only 3 times 2 times 1. But what if 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of you in this room now. And I had 8 chairs lined up. I want to find how many different ways 8 people can be in order in this 8 chairs. Well, that would take a while to do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So we have a factorial. Factorial does the same thing. And on your calculator, it looks like an exclamation point. So 3 factorial means the same thing as 3 times 2 times 1. Same as 8 factorial means the same thing as 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So we're going to slide to our calculator for a second. So to the calculator. Now, right now your calculator looks like this. I don't see anything that looks like an exclamation point. You've got to click function. So you're going to click the function button. Down at the bottom here, these are the 3 buttons we're going to be using today. These are our probability buttons. So factorial is this way. So the 3 one would be 3, hit the button, 6. So 3 factorial was 6. So the one on you guys, I had 8 students. And if I want to figure out how many different ways you guys can be ordered into seats, if I had 8 seats, factorial, 40,320. So there's 40,320 different ways 8 people can sit in 8 seats. That's the factorial button. Did everybody find their factorial button?
Yeah.
You okay? Let's go back to the worksheet. Now, that's if everybody that is available, you're ordering. But sometimes you're not always putting everybody in order. You're not putting everything in order. So if you have more items to choose from than you need for a permutation, you can do this special formula. So this P stands for permutation. And I'm using permutation because order is important. So this is our formula. So N is the total number there are. R is how many I'm picking. And I can put it into this formula to figure out how many different ways I can put it in order. Now I'm going to show you how to use the formula. Then I'm going to show you how to use the button on your calculator. A car dealer has 5 cars. So that's the total number of cars. I want to put 3 of them in order. So it's a permutation 3. So if I wanted to do it the manual way, the long way, the top number is N, so that's 5 factorial, divided by, you subtract the 2 numbers, 5 subtract 3 factorial. Well, 5 factorial is going to be 120 divided by 5 subtract 3 is 2. 2 factorial is just 2 times 1, so that's 2. So I get 60 ways. So if I have 5 cars, and I'm putting 3 of them out on the showroom floor, there are 60 different ways I can put those 3 cars on the showroom floor. 60. Now, let's take a look at the button. Back to our calculator. So on the calculator, down here you'll see the NPR. That's your permutation button. Click that first. Then you get a parentheses that shows up. The first number you put in the parentheses is how many total things you had to pick from. So he said he had 5 cars. Oop, not 56, 5. Comma, how many different you had to pick. He picked 3 cars. And I still got 60. So that's how the Desmos calculator works. On the state test, you get a calculator like the Desmos. Now the Desmos works a little bit different than like this one. On this one, I got to put the 5 in first, then hit the NPR button, then the 3. But the calculator you got for the state test is like this one. So for example, there's 8 of you in here again. So I have 8 people. And let's say I've got 3 different errands that need to be run. Someone needs to go to the office. Someone needs to take something to Tate's room. Someone needs to go to the cafeteria. So I've got 3 different things going on. So the order was important because I had 3 things. So I can do comma 3. So I would have 336 different ways that I can send 3 people to the office, to Tate's room, to the cafeteria. So that's permutation. The order matters because maybe there's different things going on. I'm putting things in order. I'm lining things up. Permutation. Are we okay with permutation? Did everybody find the button and got the button to work right? Combination. Combination is, for example, you got 6 sweatshirts and you're picking 2 to go camping. I'm just throwing them in the suitcase. I'm just throwing them in my backpack. I don't care if I pick the blue, then the red, or the red, then the blue. They're just going in my backpack. So therefore, combination is where I don't care about the order. Doesn't matter how they got lined up. I'm just picking 2. So again, there's a formula I can use. I lost my other exclamation point, my other factorial. It should be back here. So put an exclamation point there for factorial. So on this one, if I were to do it kind of the manual way, I've got 6 sweatshirts. Combination, I'm picking 2. So it'd be 6 factorial divided by the R was 2 factorial times 6 subtract 2 factorial. Now, chances are you're not going to remember that formula even in the 2 weeks before the test. So that's why I show you how to use it on your calculator. But I always think it's important that you know where this number comes from. It's just not some miraculous number that shows up out of nowhere. So on this one, 6 factorial would be, try that again, 6 factorial, 720. 2 factorial is just 2. 6 subtract 2 is 4. So 4 factorial will be 4 times 3 times 2, which is 24. So 720 divided by 48 gives me 15. So that's the formula. That's the formula if you want to use the factorial button. There's another formula you can use if you don't want to use a factorial button, and I'll show you that one here in a little bit. But chances are you're going to use your button. So let's take a look at how we can do it using our button. Everybody good? Can I move to the calculator? So on the calculator, this time it was a combination. So combination. They had 6 sweatshirts. They were picking 2 to go camping. I get 15. So that's how you use the combination button on your calculator. So for example, back to the 8 of you. There's 8 of you. Let's say I've got a bunch of boxes that need to go to the office. I send 4 of you to the office with boxes. You're all going to the same place. You're all carrying boxes. So it wouldn't matter what order, because you're all carrying boxes. So it would be 8 comma 4. There'd be 70 ways I could send 4 of you to the office. 70 ways. So combination is if I don't care about the order. Maybe I don't care about the order because everybody's doing the same thing. Maybe I don't care about the order because I'm just kind of picking a group and they're doing something. I don't care. Did everybody get the combination button okay on their calculator? Now some examples, some practice problems. Number 1, a sandwich shop. 3 bread, 2 cheese, 5 deli meat. I can pick one of each. How can I figure out how many different sandwiches you can order? What am I going to do on number 1? Kind of like my hat and jacket problem. Kind of like my pizza problem.
You start off with the 30.
So 3 breads. And then what operation do I have to do? I mean, I could do 3 things, 2 cheeses, 5 deli meats. But that would take a while to make a tree. So instead of making a tree, what can I do with the 3, the 2, the 5? You can just multiply. So the fundamental counting principle says you can multiply those 3 numbers as long as you're only picking one of each. And that'll give you how many different ways they can be ordered. So in this case, it's 30. So this is 30. Now I want you to take a moment, using your calculator on your computer, find the next 3 answers. Find the next 3 answers. 4 permutation 2, 5 permutation 2, 9 permutation 4. Then I'm going to show you another way you can kind of do it by hand. Like I said, I know you probably won't remember it, but I like you to kind of know where those numbers come from. So 4 permutation 2, what did we get? 5 permutation 2, 9 permutation 4,
3,024.
Now, you can just use your button. Another thing you can do other than that formula that I put on the front, and this one actually isn't too bad. The first thing I picked, there was 4 things to pick from. Then I picked something else, but now there's only 3 things to pick from. And then I was done picking. So 4 times 3 would also give you the 12. So same here. I had 5 things to pick from. The next thing I picked, I only had 4 things to pick from. I only was picking 2 things, so I'm done. So 5 times 4 is 20. This one I had 9, then 8, then 7 times 6. So 9 times 8 times 7 times 6 would also give me 3,024. So that's not too bad. It's just another way you can kind of do it manually. And how many ways can you order 6 objects? So I have 6 things I want to put in order. Maybe I've got flower pots. Maybe I have magazines I'm wanting to lay out. And I want to figure out how many different ways I can put these 6 things in order. What am I going to do? If I have 6 things and I'm putting all of them in order, what can I use if I'm putting all of them in order? You can do that. Usually we go the other way. 6 times 5 times 4 times 3 times 2 times 1. I mean, that will work. But instead of going all the way down, multiplying, there's another special button on your calculator. What was it? The exclamation point, which was the factorial. So 6 factorial also gives it to you, because factorial means you're multiplying everything down from that number. So 6 factorial, or 6 times 5 times 4 times 3 times 2 times 1, was what? 720. Number 6. I have 5 people running in a race. And I want to figure out how many different ways I can have a first, a second, and a third place winner. Order is definitely important. Because I got a first, a second, and a third. So I can do 5, because that's how many total people were running the race. Permutation, because I care about the order. First, second, and third is 3 people. So 5 permutation 3.
I'm just gonna say now, and I did the math already. And go to the first one.
And I'll leave that. Next.
Just go this one and then check it out, have this go down.
You might want to check in.
Thank you.
So 5 permutation 3, 5 permutation 3, 60. So if there's 5 runners, there's 60 ways I can have a first, second, and third place winners. 60 ways. So 1 was basically fundamental counting. 2 through 6 was permutation. Any questions on this? Next part. 7, 8, 9. You're using your combination. Again, go ahead and do it on your calculator, but I'm going to show you another way you can do it. So do it on your calculator. Now I'll explain what way you can do it manually. That's kind of like the formula, but not quite. I've been going through the pencils lately. Goodness. And go on pencil. So 4 combination 2, what did we get? 6. 4 combination 3, what did we get? 4. 9 combination 7, what did we get? 36. So the combination numbers are generally going to be smaller numbers because I don't care about the order. If there's 3 things going on, I don't care about what 3 things the order is in. Maybe we just want to know that if you qualified to go to the next race and the first 5 people qualified, it doesn't really matter how they cross the line. It's just those 5 qualified. Now, the other way you can do this, and like I said, I'm not necessarily expecting you to remember this. Kind of the same thing as we did with permutation, 4 times 3. But because there is 2 things I picked and I don't care what order those were in, I can divide by 2 times 1. So 12 divided by 2 is still 6. That's another way I can do it. It's a different formula than I used the first time that doesn't use factorial. So like this one, 4, 3, 2. But then these 3 things I didn't care about the order. So 3, 2, 1. 24 over 6 was 4. Now those aren't too bad, but as you can see with 9, it's just annoying. 9, 8, 7, 6, 5, 4, 3. 7, 6, 5, 4, 3, 2, 1. Okay, that'd be annoying to type in. So we use our calculator. Number 10. How many combinations of 3 objects can I do from 7 objects? You went the wrong way. There's 7 total, so 7 goes in first. Combination 3. So remember, the total has to go in first. So 7 combination 3. Seven combination 3. Yep, 35. And same on the next one. A runner has 8 pair of running shoes. So 8 total shoes. Combination 4. So 8 combination 4, 70. So 70 total ways to pick 4 pairs of shoes out of it. Questions? All right, I'm going to go ahead and stop this.
Oh, you recorded.